All right, so I think I'm recording. Here we have a table, and this table describes input and output for two functions, f and g. And it's a discrete table. It doesn't give us the input of decimal numbers or irrational numbers, and only a few negative numbers. So we're going to solve these by substitution. We don't have a formula to substitute in the input, but we do have a table where we can read off the output given the input. So let's jump in and take a look at A. It's asking us to evaluate this function h when x is equal to 2. Well, how is this function h defined? It's defined through a function composition. It's saying that if you take f composed with g, you'll get h, and this time it wants the input to be 2. So what we want to do is start out with that right function, start out with g. And if you need to think of it like an assembly line, like a picture, you can think of it like this as well. And the input into g is 2. And the table is going to tell us what the output of g is. So when x is equal to 2, the table tells us that g evaluated at 2 is 3. So now the input for f is 3, and the table will tell us what the output of f is. When the input is 3, the output is 5. And so that's our final answer, that h evaluated at 2 is equal to 5. All right, let's come in and do part B. Again, it's a composition. It's asking us to evaluate this function h, and it's not giving us a table for h, but it is telling us how we can construct h, that h evaluated at 0, well, h is the composition g composed with f, so we want to evaluate it at 0, which means that f is the input into g, and the input for f is 0. So when x is 0, the output of f is 3. And when g evaluated at 3, when the input is 3, g gives us a 2. So what this, if you prefer this assembly line picture, what's going on here is that we're plugging a 0 into f. And when we plug that 0 into f, the output is 3. And when we plug that 3 into g, the table tells us that the output is 2. So our final answer in part B is 2. You have to admit there was no arithmetic involved at all. I didn't add any numbers together or subtract or multiply or divide. There was nothing complicated. All it was reading values from a table, but the difficulty is knowing which values to read. And that can easily be figured out with a little bit of practice. Here, h evaluated at 1. Well, h is defined to be, here again, this is a function composition. G, the f is the input for g, and we're replacing x with 1. So 1 plus 2, now here's, I can do that arithmetic. 1 plus 2 is 3. So I use the table. What is f evaluated at 3? When x is equal to 3, f is 5. What is g evaluated at 5? G evaluated at 5, well, here's x equals 5. G evaluated at 5 is 8. If you prefer thinking of it like an assembly line, the input for f, well, it's the original input plus 2. That's what you always do. Whatever we're giving it the function, before we plug that number into f, we're adding 2 to it at the very beginning. So 3 goes into f, and what comes out of f was 5, and 5 goes into g, and what comes out of g is 8. All right, move on. In part D, again, it's a composition. It's f composed with itself. They could have written this as, they could have defined h of x and wrote it as f composed with f of x, because that means f is its own input. All right, so what do we have here? They want us to evaluate this when x is equal to 2. Well, we replace x with 2. So f evaluated at 2, we come over here, and when x is 2, the f is 3. So now we evaluate f at 3, and f at 3 is 5. And as far as our assembly line idea goes, we've got f, and then we have another f, and the input to f was 2, and the output was then 3, but then that became the new input for f, and that output was 5. So h evaluated at 2, the input here gives an output of 5. That's what it's asking us to find. So here the toughest thing was the toughest arithmetic was what is 1 plus 2. There's no other more complicated math than that. All right. In part E, they're asking us to evaluate this function h at 3. But they're defining h to be this function composition, f composed with g, and you take the input, in this case 3, you replace the x with 3. So before we even get started on plugging any numbers into the functions, with 3 minus 1 is 2. And so now the input for g is 2, and the table will tell us that the output, when x is 2, the output of g is 3, and when f is 3, the output is 5. As far as an assembly line goes, g is the first function, f is the second function. The input into g is always the original input minus 1. The original input was 3, and 3 minus 1 was 2. And when we inputted 2, we got an output of 3. And when we inputted 3 into f, the output was 5. So whether you think of it this more, I don't know, algebraic type method towards getting the final answer, or an assembly line, either way will get you the correct answer. Just depends, I guess, on visually which one you like better. Or use both, one as a check. All right, finally here, we want to evaluate h at 0, and h is defined to be a subtraction. And the first term is a function composition. Well, that's the same as fog, evaluated at 0. Then our second term is the composition in the other direction. So we can use the table here and say that g evaluated at 0, when x is equal to 0, g is 1. So this is f evaluated at 1. What am I going to replace this f evaluated at 0 with? When x is 0, f is 3. So now I come in and say h evaluated at 0. Well, what's f evaluated at 1? Well, from the table, when x is 1, the output of f is 1. And 3 here, g evaluated at 3 is 2. And 1 minus 2 is a negative 1. So our final answer is negative 1. So I hope that helps, and I'll talk to you later. Bye.